A digital representation of a finger joint laser cut box set of plans. We're going to generate those with Makercase.com. This is a great tool that you can use to automatically generate boxes designed around the finger joint technique, and especially for laser cutting. In the end, it's going to look like this. We get 6 sides that are all equal, so it'll be a square box in our case, but you can make them almost any dimension. You can make them rectangular, and there are other generators that produce more complex shapes. We're going to start with just the basic shape here as you see it. I've colored each shape a different wood texture just so that we can see how it works and how it is held together. Okay, first starting over at Makercase.com, I've selected the basic shape, and we're going to work in millimeters. The next step is to consider what our width, height, and depth needs to be. In my case, I'm going to measure this based on the outside of the material. If you have a desired size that is, for example, you're putting something in it and something in it has to fit, then you're going to look at an inside dimension and you're going to modify these numbers as needed. The material thickness is the big deal for this type of technique. We need to think about how thick is the actual material and how much tolerance do we need between each piece in order for it to fit well, to compensate for any errors, and also to consider how much material is removed when the cutting operation happens. So this kerf, or the material that is removed for our laser, is going to be about 0.1 millimeters. But I also want to create some tolerance so that each part isn't painstakingly exact to put together. So if I've got on my standard material, it happens to be 2.8 millimeters, and then also the cut is 0.1 millimeters, but I want some tolerance, I tend to round that over to 3 millimeters. And that will work well to be a nice good fit, a little bit of room for glue if I wanted it to be glued, but not too tight. Next, I'm deciding if it needs to be an open or closed box, and mine's closed at the moment, and I'm using the finger type of edge joining here. The finger size is mainly an aesthetic one, although you don't want something completely tiny because it increases the complexity for putting it together. You can. Or something that is quite simple, doesn't give us the best joint. So I would say just a couple fingers at a box that's 100 millimeters square is pretty good. So something like that or something like that. But if you prefer more, give it a shot. Okay. So when I download those plans, I'm presented with a flat version of the box. These are the plans that we're going to use over in Fusion to recreate it. So we're going kind of backwards in this one. The labels, I actually don't need the labels to be imported into Fusion, which is the next step, so I've removed the labels. Otherwise, the defaults will be fine. I'm going to keep the panels separate, and I'm not going to account for any kerf or corner cutting here, compensation, because I've already considered that when I entered my numbers. I'm going to download it as a DXF file. This is a traditional file used for laser cutting, and I'm going to import that into Fusion. So after I click download to DXF, I'm going to note where it goes, whether it's my download folder, desktop, or wherever it's going for you. And then I'm actually going to turn the labels back on to use as a reference because it will help me out. The front face will be my reference face, onto which I'm going to attach the left, right, back, bottom, and top to it so that it makes sense. Doing this digitally really helps me understand how to do it when I do it in real life when it's cut. Back over to my finished example, we'll go to the design, and then I'm going to show you just a quick preview of what it's going to look like. First, we'll get the DXF in as a sketch. Next, we'll extrude it based on a material thickness. Next, we're going to start assembling each piece like that. If I wanted to make aesthetic or other changes to each of these pieces, I can do it as a cube, and I could reflatten it for manufacture, or I could do it here in this sketch. I can do it all kinds of ways. But since I'm not making modifications right now, this is where I'm going to start. Okay? Starting with a new design, with a new sketch, I'm going to insert a DXF. That DXF I'm going to insert on, in my case, the bottom plane. And I'll select that DXF file. Here I'm pointing to the one that I had previously downloaded. I'm going to insert from my computer over from the desktop. The box.dxf is my file because I had saved it on the desktop. Fusion will want me to just remind it where that plane goes. There we go. And here I get the labels as well. Actually, in my version, I forgot to turn off the labels, and so I can really quickly do that by selecting which layers I wanted, or I could leave them and include them in the extrusion. But quickly, if you forget to turn them off, then go ahead and just turn them off layer by layer, and they are called the label layers. So each one of these that has label written in it, we can remove. Better for you that you just don't forget. Okay, so I've removed all of the labels because they'll just be in my way for my extrusion actions, and I'll hit OK. Now I need to extrude these, and I need to extrude them in the same amount that I set my material thickness to. In other words, they need to be the same amount as this line here. And this line, if I was to go and measure it, I would know that it's 3 millimeters, and so that's what I'm going to extrude here for. At this stage, it's helpful to apply a material to each of these. You can apply random materials. Here I'll search for wood, and I'll apply a different material to each face just to give me some sense of where things are in space in relation to each other, because working with nearly identical gray parts just isn't that easy or fun. Okay, so I've got 6 almost distinct looking faces that I can assemble. The next part is a fun part, which is putting together these pieces digitally. I know that this bottom left corner is my front piece, and if I look over at the reference diagram, I know that that's where the front one goes. I'm going to attach the front one to the left one, okay, because I'm going to work on the front one as the reference. So if this part is supposed to be on the left of the front, then this tab needs to go onto this corner here. Fusion gives us a tool for that called Align. And I can align a joint origin produced from the center of a face, so this face, not just the face though, not here, not like that, specifically the origin there. And I'm going to bring that and bring it to its matching face, which is on the other side of this tab here. So there's going to be some camera rotations. This is why we colored them differently, so that we can keep track of where we are. And I need to go very specifically here, okay? And because this face is the front face, then I'm going to use the angle button here to just rotate through an angle, keeping this front from my default view so that I can keep track of where I'm at. Okay. Next is the right panel. I know that that's the right panel because it's in the top center. And again, I'm going to use the Align tool. I'm going to select a face that I can use to connect to the other one. And in this case, because I'm going to target this area, then really I should think about using this side of the panel. And so I will use this face here. And then thinking about where that goes here. So it's like digital puzzle building. And then I'll angle that at the correct angle. While I'm doing this, I'm watching that I'm not making anything interfere, that is to say overlap with each other, because all of these pieces should go together completely correctly. Now I'll look at the back face, that's the top left face. And the back face is going to be aligned. There we go. And I'm going to put it back here. So in order to do that, I just have to choose really almost any of these, but I will align this interface with its mate over here. Now it's a good idea if you sort of plan where this is going to go just before you start moving around a lot, because it's very easy to lose track of your orientation in 3D space. 2 more to go. We've got the top and the bottom that were on the right and left. Okay, so the top, or sorry, on the right side, on the lower and upper row, top and bottom. So this is the top. So I'll take that top, find my face, and create that alignment. There we go. Now, the Align tool is just one tool that we could have used for this. We could have used a Move tool that would have been very inefficient and very difficult to get these pieces moved into space, because Move would have required us to translate it by distances. But another tool that could have worked would have been the Joint tool, and we could have created rigid joints or connections between each of these pieces. The Alignment tool, I think, is just perfect for what we want, though. And the last piece, I'm going to bring this face, and I need to look at that face and say, okay, it's over here. That must mean it goes here. Change its angle. Okay. So there I have it. The pieces all perfectly intersect with each other, and all of the corners all are logical and make sense, and they're not overlapping. Now, some fun things you can do from here are you can play with how the faces actually look by creating sketches onto the faces after the box is built. You could have also done that before. But if I create a sketch, let's say, on this face, it can be very easy for me I can create a circle here, and if I extrude this circle, I can modify that other face. And what will happen is when I go to manufacture this, both of these parts will be exactly lined up. I can even make it so that this hole is, by creating a taper angle on the extrusion, larger, but there it is still lined up with that hole. So it's a good way to make a box design where it makes sense in Fusion and the modifications are aligned. There we go. So we'll end it off with the rendered version of it. It's got a hole on the top and a larger hole in the bottom. Okay, hope that's helpful.